11.7, more about graphing quadratic functions. Now that we know how to graph a quadratic function and we know how to identify the vertex, whether it's a maximum or minimum, and the axis of symmetry, but all of that we did when we already had our function in this form. This is called standard form, f of x equals a times x minus h squared plus k. But now, what if it's given to us in general form, where everything's been worked out? Well, in order to put it in this form so that we can extract all that information, we need to complete the square. So let's go ahead and complete the square in this one. So the two main terms that we need are basically your quadratic and your linear term, meaning the term that has the variable that's squared and the term that has the variable with the power of 1. So this one we're going to just keep there, push it a little to the side. First thing, we need to always have a 1 in front here, which in this case it does. Now, we don't want to complete the square where we move things to the other side or add terms to the other side because we have an f of x and it won't combine. So we're just going to stick to one side. So in this case, we just have to make sure we keep balancing everything out. So looking at these two terms, we need to figure out the coefficient of our linear term, which is that b value, which is -8. So what do we do again? You take -8, you divide it by 2, and then you square it, which gives us -4 squared equals 16. Now, what do we normally do? We would add 16 to both sides. But since we don't want to do anything on the left side, how can we still add the 16 but maintain the balance without basically changing the value of this function? What we'll do is, you always want to add it after the second term. We're going to add 16, but we'll also subtract the 16, and then don't forget the plus 2. So now what was the point? Let me go ahead and underline the 2 new steps that we did in here. What we did here was, if you think, we added the 16 because we needed it, but we also wrote minus 16, so essentially 16 minus 16 is equal to 0. So we didn't actually change the value, we just changed what it looks like. Now the whole purpose of this was to get a perfect square. The first 3 terms give us a perfect square of what? It'll always be a binomial of whatever we got when we divided by 2. So x minus 4, that quantity squared, and then these two are like terms which can be combined. -16 plus 2 is -14. So now we have the function f of x equals x minus 4 squared minus 14, which is exactly the form we wanted. From here, we can go ahead and identify the pieces. What's our vertex? Our vertex is 4, -14. Is this a maximum or minimum? Well, we need to ask ourselves, does this open upward or downward? Well, there's a positive number, +1 here, so that means it opens upward, which makes this a minimum point. And what is our axis of symmetry? Our axis of symmetry is the line x equals 4. Let's try another one. So in this one now, to complete the square, remember we have to have a coefficient of 1 in front of our squared term. So in this case, since we have a 3, we can't divide it to on both sides like we were doing when we were solving quadratic equations, because in that one we had a 0 on the other side. But in this case, we don't have a 0. So what do? Instead of dividing both sides, what's the other way we can separate the 3 from the x squared? We can factor it out. So we'll factor it out, and we'll just factor it out of these 2 first terms because those are the 2 terms that we really need to complete a square. So we'll leave the 7 there, just a little off to the side. So we'll factor out the 3, leaving us with x squared minus 6x, and then plus 7 on the outside. Now we need to complete the square on the inside. So once again, we'll take that b term of ours, so -6, we'll divide that by 2, and we will square it, which gives us -3. That quantity squared is equal to 9. So remember, what do we do again? We will add 9 right after the second term, and then we will subtract it to balance it out. And remember, we are inside this set of parentheses, so we must stay inside that set of parentheses. So x squared minus 6x plus 9 minus 9, so that balanced everything out, plus 7. Now, within this set of parentheses, these first 3 terms gave us a perfect square. So now when I write this, I'm actually going to write with brackets. This now is the square of the binomial x minus 3 squared, right? It's always what we got when we divided by 2. And then minus 9 plus 7. Now, if this doesn't quite look like it's in standard form yet, what we need to do is open up this set of brackets by distributing this 3. So we ask ourselves, when we distribute this 3, how many terms do we have? Well, inside this set of brackets, we have 1 term and we have 2 terms. So we're going to go ahead and take this 3 and distribute it by multiplying it here and here. Okay, so let's see, what do we get? Now, we don't want to open up this set of parentheses. That wouldn't make sense. We'll just go ahead and multiply the 3 in front. So that gives us 3 times x minus 3 squared. And then 3 times negative 9 is negative 27. And then on the outside, plus 7. And now we see that these two are like terms. So we can go ahead and combine those. So we are left with f of x equals 3 times x minus 3 squared, negative 27 plus 7 is minus 20. Now we have it in standard form, and we can go ahead and identify the important characteristics. So what is our vertex? Our vertex is the point 3, negative 20. Is the vertex a maximum or a minimum? Well, the coefficient of our first term, our squared term, is positive. That means it's opening upward, which means this vertex is a minimum point. And our axis of symmetry is the vertical line x equals 3.